Hello mathematicians, welcome to a little corner of the internet called Marshable Math. My name is Mr. Marsh. Today we're going to be discussing how do you figure out an equation of a line when you're given two different points. It's a little more technical than we had last time with being just given a point and the slope, but we'll talk about that. So by way of review, let's discuss a couple things over here on the board. The first thing is that a point is a location in space. It's given by what's called an ordered pair. You have your x value first, followed by a comma, then your y value. So let's see, for example here, this point in space right here would have the ordered pair of the x value is to the right, 1, 2, 3, 3 units. And the y value is down 1 unit, so that would be a -1. Points are always given as ordered pairs, not the same thing as slope. But what is slope? It's my favorite topic in all high school math. Slope is going to be the change in the y value over the change in the x value. Not what the x and y values are, it's how they change. Okay? So this is just a little shorthand here, delta y over delta x. The delta, again, remember, means change. The full formula says that m is equal to y2 minus y1 over x2 minus x1, where x1 and y1 are your point values, right? So if I wanted to say what the slope of a line here would be, I have to find some kind of change. So let me see here. Let's say that the change is going to be, I don't know, +2 over +5. So that means I'm going to go up 2 and then 5 to the right. So up 2, 1, 2, and then 1, 2, 3, 4, 5. That's that location over here. Notice it's not the point 25, it's the slope 25. Slope tells you how you go from one point to the next. And if I wanted to, I could then draw the line between these. Slope-intercept form is the form of an equation of a line where your x and your y are simply any solution point values, they're ordered pairs. And m is the slope of a line and b is the y-intercept. The y-intercept is then where it crosses this y-axis there. And so perhaps maybe we could add a little bit here. We call it the slope y-intercept form of a line because that's what it tells us. Point-slope, the point-slope formula is basically a modification of this formula right here, where your y2 and your x2 were actually just the x and the y as part of the equation. So if you know the point values, your x1 and y1, and you know the slope, you can simply substitute those things in here and do some algebra to simplify, and it will give you this form of a line right here. And that's one of the things that we're going to do today. Next one, what is the graph of an equation? What is it? Okay, it's actually the collection of all the solution points to that equation. So it is the collection of all solution points. And then next, what's needed to find the equation of a line? This is what we did last time on the first equation video. You need a single point, a solution point. So what's S-O-L-U-T-I-O-N? A solution point and a slope. Okay, so these things should be familiar to you. We're going to move on now to the lesson. So how do I figure out the equation of a line when I'm just given 2 points? Well, we need, again, from that last review point, we need the slope of the line and a solution. So let's take, for example, the following. What if I've got these 2 points here? What if I've got 3, 1, and then 6, -3? Well, I could plot them, I could draw a line and stuff like that, but how do I figure out what the equation actually is? We need slope, and we need one solution point. We've got 2 actually. So let's find the slope. Not hard to do. I'm going to show you a little trick though. Maybe I've shown you this, maybe I haven't. I like to take the 2 points, if they're integers, if they're whole numbers, right? And I like to stack them on top of each other. So I'll call this one 6, -3, and notice I'm just writing it underneath here. Okay? What that allows me to do is it allows me to do just a little simple math. If you can track it in your mind, the reason I stack these is because I like the x value and the y values to be kind of in the same column. So what I'm going to say then is slope is equal to my change in my y value over my change in my x value. I always write the formula down first, right? Anytime you use a formula, always write the formula down first. And then I'm going to do this. I'm going to say, well, here's my y value. If I start from 1 and I go to -3, what kind of a change is that? Okay, haven't I gone down 4 units, right? So that would be a -4. So my change in y then is -4. Then with the x's, if I start at 3 and I go to positive 6. How is that a change? Haven't I increased by 3 units? So that would be then a positive 3. And look, there's my slope right there. You can go from top to bottom or bottom to top. It doesn't really matter which one, but top to bottom is more natural. But also, once you make a decision for your y value going from top to bottom, you have to do the same thing with your x. You have to be consistent with that. You have to go from top to bottom here. You say, whoa, Mr. Marsh, that was like math voodoo. How'd you do that? Well, it's the same thing as using the slope formula. Let me show you that one. We said slope was y2 minus y1 over x2 minus x1. All I'm doing here is doing the change in the y over the change in x. What do I get? I get, well, the second y value is negative 3, and then minus a 1 over the second x is 6, minus the 3. You can see where that's going, right? That's the same thing right there, right? Okay, so the slope then is going to be negative 4/3. I know that. Okay. Now what I need is a point. Which point do you pick? You've actually got 2 of them. It doesn't really matter which one you pick. So which one do you want? Do you want the top one, the 3, 1, or do you want the bottom one, 6, negative 3? Pick one. Well, if you're like me, you pick the top one, and maybe you're not quite sure why, but I know why. I don't like negatives, right? Numbers or people. I have to deal with them from time to time, and I can handle that, but I would prefer to use positive numbers if at all possible. So I'll pick the top one, and actually it doesn't matter. I'll show you both here in a minute. So let me pick the top one. The point I'm going to use is 3, 1. And then I'm going to use my point slope formula that we had during the review. The point slope formula says the y minus the y value is equal to the slope times x minus the x value. All right? So the y minus the y value, what's the y value? 1. Substitute that in there. Is equal to the slope. What is that? Negative 4/3. So negative 4/3. Then x from the formula minus the x value. The x value then would be 3. Okay? And now I simplify. Don't let the fraction scare you. You're the boss of the fraction. You manage it properly. I'll show you a little trick here in a second. But let me distribute the negative 4/3 through. So what I get then is I get y minus 1 is equal to negative 4/3 times x is negative 4/3 x. Oh, look at this. Isn't this beautiful? I love it when a plan comes together. Look, negative times a negative is a positive, and then 4/3 times 3. 3 as a fraction is 3 over 1. Don't these 3's cancel? They do. How convenient. Sometimes it won't, so be ready to manage that. But what I get over here is just plus 4. Now I've still got that fraction. Now let me just do this. It's real simple now from this point. Let me just take the 1 and move it over. So plus 1 here, plus 1 there. What I get in the end is y is equal to negative 4/3 x plus 5. So that's then my equation of a line in, oops, killed the 3. Equation of the line in slope-intercept form. Let's see if it actually works. Let me plot the points here and just play. So 3, 1. 3, 1 would be 1, 2, 3 up 1. That would be that location right there. And then 6, negative 3. 1, 2, 3, 4, 5, 6. And then down 1, 2, 3. Okay, and then I gotta draw my line. Oh, there's my. Okay, here we go. You thought it was going to come from that side, didn't you? Yeah, you never know. All right, so here we go. Looks like the line, right? Collection of all the solution points. It says I'm supposed to be going negative 4/3 from point to point. Let's check that. Down 1, 2, 3, 4, and then right 1, 2, 3. Looks like the slope is negative 4/3, but check this out. Remember last time we talked about this being the y-intercept? That's where it crosses the y-axis. Should cross it at 5. Look, 1, 2, 3, 4. Bingo. There it is. See? It all comes together. All right? So now what I want you to do is if you haven't already been taking notes, you probably maybe ought to copy this down, right? So go ahead and press pause in the video, take a moment to kind of duplicate what I'm going to do, what I did here, because I'm going to give you a practice one here in just a minute, okay? All right, back to it. Let me give you the practice one now. From 2 points, figure out the equation of the line in slope-intercept form. Let me have you use these 2 points. Let me have you use -2, -7, and also 0.42. Okay? Go ahead and press pause in the video. Try your hand at it. Okay, ready? What do we need? We need slope, and we need a point. Okay, slope between here and here. Let me stack them. 4, 2. What's my change in my y over my change in my x? If I go from -7 to a +2, wow, what's that? Up 9? That's an increase of 9, so +9 over, and if I go from -2 to a +4, isn't that also an increase? That's an increase of 6. And so let me reduce. I should have a slope of 3/2. Did you get 3/2? Even if you use regular old slope formula? Okay, so the slope is 3/2. All right, now let me take the slope and pick a point. The point that I like the most is probably going to be this one here, 4,2. So I'm going to use my formula here. Y minus y1 is equal to m times x minus x1, and I'm going to substitute now in. This is the y of the formula, so it stays put. Y minus the y value, 2, is equal to the slope, 3/2, times x of the formula minus the x of the point, 4. All right? Distribute that in, so I'm going to get y minus 2 is equal to 3/2 x minus 3/2 times 4 over 1. The 2 and the 4 here are going to cancel, leaving me a 2. That's going to give me a 6 here, if I did that correctly. No, wait. Yeah, 2. 3 times 2 is 6. Got it. Okay, so now add 2 into both sides, plus 2. I'm going to get y equals 3/2 x, what is that, minus 4? Do I have that right? No, how do we check? Just check it graphically. Let me plot these points. -2, -7. -2 down. 1, 2, 3, 4, 5, 6, 7. Oh, it's way down there. And then 4, 2. 1, 2, 3, 4, 1, 2. Here it is. And that should be the line. Does it go up 3 and right 2? Up 1, 2, 3, right 1, 2. There's a point. 1, 2, 3, right 2. There's a point. Okay, looks good. And then -4. Is my -4 then my y-intercept? Look at that. There it is right there. Woo! Love it. Is that what you got? Maybe you're one of the folks that actually likes the negative points. That's okay. Nothing wrong with that. Let's try that. So, new solution using the same formula. Y minus y1 is equal to m times x minus x1. But now let's pick the -1. Yeah. Okay. So y minus the y value, which is -7, is equal to the slope, which is 3/2 times x minus the x value, which is -2. Man, lots of negatives in there, right? But us being good mathematicians, we can handle negativity. That's a good thing. So this becomes now y plus 7 is equal to 3/2 times, and clean that up, what is that, y plus 2? Oops, x plus 2. Distribute in, y plus 7 is equal to 3/2 times x, and then 3/2 of the 2's here cancel, so don't I get plus 3? And then if I subtract 7, oh look, do you see where it's going? Can you anticipate it? Yeah. Minus 7, I bet it's minus 4. So y then is equal to 3/2 x minus 4. There you go. Bada bing! Alright, so review. How do you figure out an equation of a line from just 2 points? Well, you need to use those 2 points to figure out your slope first. You need your slope. And then you just pick one of the points and substitute it into my favorite formula, the point slope form. Do some algebra, simplify, you should be in. Ever want to check? Graph it, see if it turns out okay. Hope you learned something, and I hope you guys have a great day. Bye-bye.